We present a steam engine with a hydraulic transmission and a molten metal boiler. In this new engine, the crank and connecting rod mechanism is not used. In its place is a simpler and more efficient system. The steam-driven linear movement of the piston directly drives a hydraulic piston pump, and the hydraulic flow created can move hydraulic motors or cylinders. In this steam engine, the boiler is a metal container with three things inside: a metal with a low melting point, such as gallium, a radioactive metal, such as plutonium-238, and a pipe through which water circulates and is transformed into steam. The pipe and the plutonium-238 are both submerged in a liquid gallium bath, with the plutonium in spheres to maximize the surface volume ratio. The heat emitted for years and years by the plutonium travels through the liquid metal to the pipe, where the elevated water temperature produces steam. Through forced convection, the gallium will be at a homogeneous temperature, in equilibrium with the steam from the boiler, which will be at the same temperature as the gallium. Moreover, the pressure of the steam will be the same as the pressure of the pump. The pressurized steam that comes out of the boiler is directed by solenoid valves that cause a double rod cylinder to oscillate. By design, this cylinder applies the same force in both directions. The force of this steam-driven cylinder is used to move a hydraulic piston pump. With each oscillation, the pump moves oil from a tank to the main circuit. Furthermore, a hydraulic accumulator allows a constant flow towards the main circuit to be maintained, compensating for the piston pump stoppages. This new engine drives hydraulic motors, which can then be used to generate electricity or to move wheels, pumps, and machinery. Additionally, the engine can move hydraulic cylinders with thermal performance over 30%. As hoses can be used to drive the hydraulic flow generated by steam, this is the first engine in history that can have multiple output shafts in various locations, even when far apart from one another, while performing different jobs. The final result achieved by the new engine is similar to any existing hydraulic device, whether fixed or mobile. In all of these devices, there is a hydraulic pump that moves the wheels or cylinders. But in these other devices, the hydraulic pump is moved by a diesel engine or an electric motor. In the new engine, the hydraulic pump that produces the movements does not move because of a rotating shaft. Rather, it moves directly with the oscillation of a piston, driven by the force of steam. Steam has moved the world for hundreds of years, and hydraulics have been around for decades. This invention has united two proven technologies, using the strength of steam and the efficiency of hydraulics to create a new type of engine. Looking at what has been done before and coming up with new ideas is innovation. This new type of engine is also groundbreaking due to the diversity of fuels it can use. Because this engine uses plutonium-238, we are talking about a nuclear energy engine that can operate safely and efficiently for years. It does not emit radiation. It does not have any risk of explosion, and it can adapt over time to the degradation of plutonium-238. In addition, gallium is also completely harmless. Nonetheless, this engine can use all types of biomass as fuel. For example, you can make a wood pellet engine as an alternative to the diesel engine. Similarly, it can operate with solar energy, or even with fossil fuels, such as gas or oil. Because of its simplicity, its design, and its versatility, this is not just a new engine, it is a new technology.